Wind power is a sustainable and renewable energy source that efficiently converts wind energy into electricity. This clean and eco-friendly technology plays a major role in sustainable wind power generation, which helps to reduce the dependency on fossil fuels. The working principle of wind power plant is based on converting kinetic energy of wind into mechanical energy and then into electrical energy. Wind turbines harness the kinetic energy of moving air and convert it into rotational energy through the spinning of the blades. This rotational energy is then transferred to a generator through a shaft, and generator will produce electrical energy. In this video, we will learn all essential components of wind power plant like rotor, gearbox, generator, tower, etc. There are basically two types of wind turbine: vertical axis wind turbine and horizontal axis wind turbine. Vertical axis wind turbine spins on a vertical shaft, capturing wind from any direction. It typically operates closer to ground, so we can place heavy equipment like generator, gearbox on the ground. However, winds are lower near ground level. So, for the same wind and capture area, less power will be produced as compared to horizontal axis wind turbine. Vertical axis wind turbine doesn't require yaw mechanism, since it can harness wind from any direction. Vertical axis wind turbine is quieter and easier to maintain, making them great for urban and residential spots. Horizontal axis wind turbine captures wind's kinetic energy in a rotor consisting of two or more blades. Rotor is mechanically coupled to an electric generator. The turbine is mounted on a tall tower to enhance the energy capture. Various wind turbines are installed at one site to build a wind farm of the desired power generation capacity. Actual power extracted by the rotor blade is the difference between the upstream and downstream wind power. Upstream wind is at the entrance of the rotor blades, while downstream wind is at the exit of the rotor blades. The rotor turns the low speed shaft at 30 to 60 rotation per minute. High speed shaft drives the generator via a speed setup gear. Gear connects the low speed shaft to a high speed shaft and increase the turbine speed from 30 to 60 rpm to 1200 to 1800 rpm, which is required to most generator to produce electricity in an efficient manner. A disc brake is used to stop the rotor in emergencies. It can be applied mechanically, electrically, or hydraulically. Induction generator is used to produce 50 to 60 Hz AC power. The rotor is attached to the nacelle which is installed at the top of the tower, and which includes gearbox, low and high speed shaft, generator, controller, and brake. A cover protects the components inside the nacelle. Some nacelle are large enough that a technician can stand inside while working. The yaw mechanism of the wind turbine is the component responsible for the orientation of the wind turbine rotor towards the wind. That means, as the wind direction changes, the rotor will also move to face the direction of wind, so that the efficiency of the wind power will increase. A yaw motor is installed to power the yaw drive. A vane is installed to measure the wind direction and communicates with the yaw drive to orient the turbine properly with respect to wind. Controller controls the pitch of the blades and orients the nacelle to face the wind. It also manages generator torque and activates mechanical brakes when needed. Tower supports the rotor and nacelle of wind turbine at desired height. The major types of the tower used in modern turbines are lattice tower, tabular steel tower, and gauge tower. The lattice towers are fabricated with steel bars joined together to form the structure as shown here. They are similar to the transmission tower of electric utilities. lattice towers consumes only half of the material that is required for a similar tabular tower. This makes them lighter and cheaper. As the load is distributed over a wider area, this tower requires comparatively lighter foundation, which will again contribute to the cost reduction. The major problem in lattice tower is it is not good looking because it is visually unacceptable to some viewers. Similarly, avian activities are more intense around the lattice tower because birds can conveniently sit on its horizontal bars. This may increase the rate of avian mortality. Due to these limitations, most of the recent installations are provided with tabular steel towers. These towers are fabricated by joining tabular sections of 10 to 20 meter length. The complete tower is assembled at the site within 2 to 3 days. These towers are comparatively good looking and less danger to the avian population. For small systems, tower with gauge steel poles is used. By partially supporting the turbine on gay wire, cost of the tower can be considerably reduced. Usually, 4 cables equally spaced and inclined at 45 degrees supports the tower. We know that wind velocity increases with height. Hence, taller the tower, higher will be the power available to the rotor. The average wind velocity at 30 meter tower height is 8.2 meter per second. The velocity at 120 meter height is 9.9 meter per second, which means that the available power is 1.75 times higher than that at 30 meter height. Thus, the performance of the wind turbine improves with its tower height. However, taller tower cost more. Tower accounts about 20% of total system cost. Up to a tower height of 80 meter, the cost of electricity generated is declining gradually due to the improvement in the turbine performance. However, above 80 meter height, there is increase in initial investment due to additional tower height. As a result, the cost of electricity generated starts increasing. The optimum tower height for a system is site-specific issue. So friends, harnessing the power of wind is not only efficient but also essential for building a sustainable tomorrow. Among all the power plants, wind power is one of the major plants with more than 20 years of lifespan. It usually requires maintenance at every 6 months. The overall efficiency of a wind power plant is 20 to 40%. From turbine blades to generators, every part of the wind power plant works together to create clean energy for all of us. If you learned something new today, then like the video, share with your friends and comment your thoughts in the comment section. Also subscribe to the channel and press the bell icon to get the notification of upcoming videos. Till time, keep learning, keep growing. Thank you.